Start recording. Okay, we're now recording. GIS assignment 2, North American Hometown Geography Map, which is a group project for rural regional geography, and this is section A02. So I am going to, let's see if I'm going to shift into student mode so that I can hopefully see what you all see. I'll try to stay in student mode as long as it works for me. Let's see, so in student mode here and here, take us right into the assignment itself. So here's a student mode. So you have your groups, due date. And so the instructions are here: GIS assignment 2, North American Hometown Geography Map. And here are the instructions. So first, if you have already completed GIS assignment 1, you will already have an ESRI public account, ArcGIS public account. So if that is the case, then you will simply sign in, boom, and come to the map. So I'm going to demonstrate that now. You've already done it, but in case not, I'm going to go here, here. I'm going to sign in, and then I'm going to go to the map. And there we go. Okay, so that takes us down. Let me get this out of here. That takes us down to, this out of here, that's from the last class. That takes us down to step 4, which means we go on to step 5. It says each group, blah, 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 blah. So each one of you have been assigned a hometown. The next task is to enter data into a spreadsheet. So the spreadsheet has been provided, but because we're in a virtual space, what I'm going to do right now is create a spreadsheet for you all to share. So I'm going to take the blank spreadsheet, and I'm going to call it File Save As, and I'm going to call this one GEOG 1010. GEOG 1010 A02, that's you all. And I'm going to save it. No need to have a group name in there because you're all in the same group. Saved it. Now I'm going to go to my Google Drive. Oops. Didn't mean to do that. Now I'm going to go to Google Drive. Let me go here. Let's do it the easy way. Go into the drive here. And I'm going to upload that spreadsheet I just created. Where is it? Where is it? Where is it? GEOG A02. That's your spreadsheet. Open it. Pull it up. Okay. Okay, so here's the spreadsheet. Let me go here, make sure I get the right one. Okay, here's A02. Right click on it, get shareable link. I'm going to turn this from restricted to anyone with the link. Make everybody with the link an editor. Done. Right click, get shareable link, copy link. And I'm going to go, now I have to go back into developer mode now here, and go back into developer mode. Can't be a student doing this. Change role. And so what I'm going to do now is I'm going to add this link to the spreadsheet here. So that way everybody and paste that in here. And save. Okay, so now all of you should have editor's access to this spreadsheet, which is here. And I'm going to open it up from here. Well, I'm not going to mess with your spreadsheet. I'm going to go back into the demo sheet. So this is your spreadsheet, but I'm going to use a demo spreadsheet for the demonstration. Okay. So when you open up your spreadsheet, open with Google Sheets. And then here's your blank spreadsheet. So essentially what you're going to be doing is building a geographic information systems attribute table. And I'm going to walk you through that process right now. So let's say this is your group. Each person should come in. Oops. And I'm going to just add some fake names here. Okay, so in the shared space, you should type in your names and then hometown city. I'm from Baltimore, Maryland, and then Josie's in Houston, Texas, Lexington, Kentucky, Albany, New York, and let's see, Seattle, Washington. Okay, just made that up. So you can go in. Each of you should have access to this spreadsheet, to your spreadsheet that's at that link. Okay, so that's field A, your names. Whoops. And then field B, field A, field B. So in a spreadsheet, each column is called a field. So now we're on the field C, city population. Okay, notice you can't just go out and Google the city population. When we are engaged in scientific inquiry, we can't use Google as a source. Google is not a verifiable source for anything. Anybody can put anything on the internet. And so I guarantee you, if I was to ask 5 of you to Google the population of Nashville, Tennessee, you'd get 5 different answers or 4 different answers. So we have to go to a verifiable source, which is Google, which is census. It's been a long day, folks. Census.gov. So we'll go to the census site. Again, this is being recorded in case you get lost here, but try to pay attention. So here's the U.S. Census Bureau site. This is a census year, I'm sure you've heard. So we're going to go to Explore Data, the Explore Data tab first, then go to Explore Data Main, click there. And then you scroll down to Quick Facts. Click on Quick Facts. And then here's what you do for each of your cities. Type in the name of your city. I'm going to type in Baltimore, Maryland. And click there. And so notice that the population for Baltimore, Maryland shows up here in the spreadsheet. Don't get confused with this other number. That big number, 328,239,523, that's the population of the entire United States. Okay, you just want your hometown's population. So in this case, it's 593,490, which is the most recent estimate that we have, is from July 1, 2019. Some of you, if you're from well, all of you here are from relatively large cities, so you should have a pretty recent estimate. And so you would just simply type city population, 593, just like that. And then of course you would do the same for the other cities. I'm not going to do that right now. Okay, next, latitude and longitude. Okay, latitude and longitude. Latitude is the arc angle distance north and south of the equator. Longitude is the arc angle distance east and west of the prime meridian. Both are measured in degrees. Both are measured in degrees. So how do we determine latitude and longitude for your city? Well, here's how. I'm going to show you. You go not to Google, but to Google Maps. And then I'm going to go, in my case, to Baltimore, Maryland. Okay, so once you get to your city, you can pick any landmark that you want for your city. And so you don't necessarily want to pick, say, your house or your mother's house rather, or your grandmama's house, wherever it is you were before you came to TSU. Maybe switch to a satellite view in Google Maps. So I'm going to just use Mondawmin Mall. This is a mall near my father's house. It's one of those malls. It has its ups and downs. So what you don't want to do is click on any of these teardrops. That'll just mess you up. Just get somewhere in the neighborhood of the landmark. Okay, and then so I'm close enough, and then I'm just going to click one time and drop a teardrop. And if you notice, when I drop that teardrop in, I get the latitude and longitude for that teardrop location here. So in this case, that teardrop is at 39.317473 degrees north latitude. Notice that longitude is a negative number in the Western hemisphere. That's west of the prime meridian. So it's minus 76.655940. Okay, so I've got my latitude and longitude, and we go to the spreadsheet, type in the latitude. You'll do this for each city, 39.317473 degrees north of the equator, and the longitude is negative 76.655940 degrees west of the prime meridian. Okay, so that's how you get latitude and longitude. Notice I did not round those numbers off. So you should not round those numbers off, because each degree of latitude, and in some cases each degree of longitude, is about 69 miles. So what you see after that decimal is a fraction of 69 miles, tenths, hundredths, thousands, 10,000s, 100,000s, millions. So a millionth of 69 miles is a few inches. So that means that once you break that 69 miles into these very fine parts, that gives you a significantly higher level of accuracy or locational accuracy than if you, say, just left it at 39.3 and minus 76.7, let's say. So you do not want to round those numbers off under any circumstances. Okay, so just remember that. Okay, next on the elevation. Now, for elevation really is not an exact figures. So this is the one time that you can Google. Okay, this is the one time. It's not really accurate anyway. So what you should do is, let's say, average elevation Baltimore, Maryland, and let's see what we get here. Now I got an interesting answer here. So this says that, and you might get something like this. So we go from sea level, which is 0 at the harbor, to 480 feet, which is the highest elevation. What we want is the average elevation. 480 divided by 2 is 240. And so we'll put in the spreadsheet 240. Now notice I'm not going to put 240 FT, no tick mark. In any number field, you only want numbers. You do not want to have text and numbers in the same cell. Excuse me, not field, cell. You don't want text and numbers in the same cell. So you just have 240. We're just going to assume that we all know that that's feet. Okay. Next, when we start to get into some of the other fields, this gets us into the textbook. So notice it says for field G, hometown city physiographic region, textbook figure 12.1. So now we have to get into the textbook. Hopefully it's still here. Disappeared for a little bit last time. Let's see. Well, there it is. So I'm going to go into student mode just to make sure that we are all seeing the same thing. So I'm in student mode. Go here. Here, wow. Guess this makes it large enough for you to see. Okay, so if we're looking for figures, so remember this is figure 12.1, then that will get you, the easiest way is to go to images. Now we have images. See, you have the figure numbers, 12.1, that means it's in chapter 12. Scroll down, there's figure 12.1, click on it, and we get a map of the physiographic regions or physical features of North America, and you see what they are, where they are. So this kind of gets us a little head start into Unit B, but we're just using this as practice. So for Baltimore, Maryland, have to kind of look there. Here's Chesapeake Bay, there's Washington, D.C., Baltimore. This isn't the best map in the world, but we'll just say for argument's sake that Baltimore is in the coastal plain. It's really in the Piedmont region, but we just have to work with the map that's in the textbook. And so we will go back to our spreadsheet. I'm trying to do everything I can not to. And so our physiographic region for this, in this case, would be coastal plain. Okay. Probably the same for Houston, Texas. Let's say for Lexington, Kentucky, we might have something a little bit different. I'm just going to explore this a little bit. So for Lexington, Kentucky, let's see, we might say that that's in the Appalachian Mountains region, kind of, sort of. It's about as close as we can get. Again, this is not the best map in the world, but it is the one that we have. And so we'll have to work with it. I have found better maps, but we'll just use this one since everybody has access. Well, most of us have access to the textbook. So we would go here and whoops, not there, but here. And so for Lexington, Kentucky, we might type in Appalachian. Okay, so, and then of course, Albany, New York and Seattle, Washington would have different physiographic regions. And next, Köppen climate region. Again, go to the instructions. The Köppen climate region is figure 12.3. Here, here. We'll go back. And so we want to, well, I went all the way back, didn't I? Here, images, figure 12.3. Now, the Köppen climate region map is a map created by a climatologist, a European climatologist. His name was Köppen. And so here we have various climate regions: tropical, rainy, dry. So A climates are tropical rainy, B climates are dry climates, C climates are subtropical climates, and D climates, and so on and so forth. So for, it looks like Baltimore falls under this DO, which is an oceanic temperate climate. So what we'll do is go here, go here, here. And so we'll want to type in the 2-letter designation DO, and then and the climate, DO, continental temperate, oceanic temperate. Sorry about that. That's why we always double check. Oceanic temperate. Okay, so I think that you all get the general idea of how to complete at least that portion of the spreadsheet. So as you continue across the fields I, J, K, and L, you'll refer to the textbook. Figure 12.10, figure 12.28, figure 12.32. When you get to field L, next we get, that gets us into using ArcGIS Online. And so let's go to ArcGIS. We already have it open. I'm going to navigate to Baltimore, Maryland. Okay, now I'm in Baltimore, and now I'm going to look for a major body of surface water. Now, some of you probably already know what the major body of surface water near you, especially if you're from Chicago or Memphis or wherever you're from. You probably already know this. So I'm going to use the Chesapeake Bay. Obviously, you know, I just happen to know that. Imagery hybrid. So we have Chesapeake Bay. I just happen to know, for some reason the label isn't popping up. Let's try another base map. It might. Okay, no, let's see. Oh, National Oceanographic. It means Geographic should have it. Wow. Anyway, I know that's the Chesapeake Bay, even though it's not popping up. The label's not coming up anyway, but I know that's the Chesapeake Bay. So let's move across here. Major surface water body. Chesapeake Bay. Okay, next. What is the closest mountain or mountain range? So now we'll have to use the measure tool. And I'll probably need to go to a different, okay, well, this National Geographic base map has some, now this one's gonna be pretty easy for me, apparently. I don't know, let's see, there's the Allegheny Mountains and the Catskill Mountains and more Allegheny Mountains. And then of course we had the Blue Ridge Mountains. So the question is, what's the closest mountain range? So we use the measure tool here. Measure, miles, And I'm going to highlight, click on Baltimore and drag. Notice you see the miles. So the Blue Ridge Mountains are only about 78 miles or maybe even 60 some miles from Baltimore. So that answers that question. So we'll type, whoops, I keep going back to this. In this case for me, Blue Ridge Mountains. And then a natural hazard. And a natural hazard is like a tornado, flood, hurricane, earthquake, landslide, something that occurs naturally, not air pollution. Air pollution is an anthropogenic hazard or a human-caused hazard. So in this case, for Baltimore, we've had some pretty bad floods in the last couple of years. And so that's how the spreadsheet would be completed by each person in each group. Let's do this. I'm going to very quickly, since we have time in this class, I'm going to very quickly go to back to Google Maps. Very quickly. And I'm going to type in Houston, Texas. And I'm just going to get, let's see, Houston, Texas. If I can find, where's Texas Southern University in here? I can't find it. I know it's somewhere around here. Oh, it's Pleasantville. Where is Texas Southern? Yeah, forget it. Let's just use Houston Landmark. It's the 4th Ward. Oh, Breakfast Club. Okay. If you ever go to Houston, hopefully they're still open. Got to go to the Breakfast Club. So we'll use that as a landmark. Satellite view. Click close. Okay, so I've got 29.738977 minus 95.381144. There. Here. So let's see, Houston is 29.738977 negative 95.381144. And I'm going to go back to the census site. Where's the census? That's not it. Oh, whoa, I'm not doing that. Let's just go here. Census.gov. Explore data main. Down to quick facts. Houston City, Texas. 2,320,268. So Houston's, let's go here. Here. Oh, God. Sorry about that. Yeah, this all right. Houston is 2,320,268. Okay, so just wanted to fill out a little bit more of the spreadsheet. Okay, so at some point, you're going to fill all this out, and then you're going to go to File, Download, Microsoft Excel. Open that up. Here it is, Enable Editing. Okay, so then you're going to save it to your hard drive. File, Save As. Go to my special place, geography 1010, fall. Okay, so this is the, I'm just gonna call this demo. Well, I'm just gonna overwrite the demo sheet. It's gonna overwrite it, no point in saving it. Okay, so I've saved it in Excel format first. Next, you want to do a file, save as type, and then you want to save it as a comma delimited, CSV comma delimited file. There. Now, when you save it, it's going to give you all kinds of crazy yes, yes, yes. Then when you close it, same thing, save, yes. You're good. Okay, so now we've gone through step 6, which is where you save your spreadsheet. And then now we're at step 7. So now at step 7, we go back to ArcGIS online. And this is not the base map we want. Let's just go to topographic and zoom out a good distance here. And now we go to add layer from file, choose file. We want that demo. Open it up, import layer. Okay, and so you notice that we have, now here's what might come up at first. We've got your names. What we really wanted, the city names. So we go to city, hometown city, click done, go to legend. Notice that the cities, there's Houston and there's Baltimore, show up on our map. Okay, so there are your cities on the map. You can also change the appearance or change what is symbolized by going here, go to these little shapes, change style. In attribute, choose attribute to show, we can change this to city population. We did do city population, and watch what happens when we do city population. Notice the symbols change to more of a quantitative representation. And so you notice that now we have the city's point symbols represented as proportional diameters of these circles in the legend. So you know that, so you'll get the relative sizes of your cities. And then of course you can always click on each city to get the data that's stored in the attribute table. So I clicked on Baltimore. So the data we just entered pops up there. And then of course, when we click on Houston, we get the data that I just entered for Houston, of course, not complete. So now, the next thing that you'll do is obviously save your map, save it. So I'm gonna call this GEOG 1010 A02 demo. You should have at least one tag, save the map. Then after that, you share the map. Everyone, make sure it's public. Here, whoa. Okay, should be a link coming in there. Maybe things are going slow today. We try that again. Share. Let me try that again. Okay, what? Okay, well, that's strange. Okay, man, these things are, okay, so you should get a nice simple URL, link like this one. The computer was doing some interesting things there. Copy, and then in the instructions where it says to copy and paste your map link in the space below, just paste it there, make the link live. So now I should be able to see your map if it's public. Okay, well now it's public after I hit that done button. Okay, so then you will upload this entire sheet and your Excel and CSV data sheets that you download to your hard drive. As a matter of fact, each of you should have the same data in your drop boxes. Okay, so it's only one class, one group. And this course, this Word document should be in each person's box. Even though you only need to have one person's ArcGIS account with the map in it, if I were you, I would have my own account with the map on it, which is very simple. You just get the CSV file, add it to the map. And so therefore next week, when we come back to class to do the map demonstration, and let's say the person that said, oh, I got the map, I'll be there next Wednesday. For every reason, if that person doesn't show up, like I said, gets called in work, family emergency, who knows, they're not here, at least you will have your own copy of that map so that you can do the map demonstration. For next week's map demonstration, each of you will have to demonstrate some functionality of the map. Either you can change the symbols, or figure out how to change the base map, or show me the population or the elevation compared to the other cities, or something else. Okay, so as a matter of fact, I'm just going to ask you, can you use the measure tool to show me which mountain range is closest to your hometown? Okay, so be prepared to do that. Again, if you have any questions about that, please let me know. Okay, so I'm going to stop recording at this point.